Series and mathematical induction. Sequence, it is a function whose domain is the set of positive integers. Note, a sequence is said to be an infinite sequence when the domain is a set of all positive numbers. If it is finite sequence, if the domain is a finite of all positive integers. The value in the sequence are called terms. Example 1, 3, 5, 7. Value sequence are called terms, where f of n is equals to a sub n. It means it doesn't actually the range of the function. So 1, 3, 5, 7. F of n is equals to 2 times n minus 1. So where the domain is a set of positive integers as 1, 2, 3, and so on. And then we will substitute 1, 2, 3 in the formula of f of n 2 times n minus 1. So we will try f of 1, which is f of 1 is equals to 2 times 1 minus 1 is equals to 1. So f of 2. So 2 times 2 minus 1 is equals to 3. S of 3, which is 2 times 3 minus 1 is equals to 5. F of 4 is 2 times 4 minus 1 is equals to 7. And so on. Series and sequence. Series, it is the terms of sequence, while sequence, which is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. It has associated with a series, and sometimes we will add this as a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5, and so on. So formula for the n term and an arithmetic. So a sub n is equals to a sub 1 plus n minus 1 times the common difference of d, where a sub 1 is the first term, and n is the number of terms, and d is the common difference. For the formula of arithmetic series, which is s of n is equals to n divided by 2, a sub 1 plus a sub n, where s of n is the sum of all terms, while a sub 1 is the first term, and a sub n is the last term. Example number 1. Find the first term of an arithmetic whose 10th term is 25 and whose common difference is negative 0.5. So what will be the solution? First, we will write the formula of a sub n is equals to a sub 1 plus n minus 1 times d. And then we will substitute the a sub n, which is 25, and n, the number of terms, which is 10, and d is negative 0.5. So we will find a sub 1. A sub n is 25, and then 10 minus 1, which is 9, times negative 0.5. So a sub 1, so 9 times negative 0.5, negative 4.5 is equals to 25. So a sub 1, 4.5 plus 25. So a sub 1, or the first term, will become 29.5. Problem number 2. There are 15 rows of seats in an auditorium, with 8 seats in the row and 2 additional seats in each succeeding row. How many seats are in auditorium? So we will find the last term, and we will put the formula a sub 15 is equals to a sub 1 n minus 1 times 2. So we will substitute a sub 1, which is 8, And then n is equals to 15 minus 1. And the common difference is 2. So a sub 15 is equals to 8 plus 15 minus 1 times b. And then 15 minus 1 is 14 multiplied by 2 plus 8. So 14 times 2 is 28 plus 8. And then at the same time, a sub 15 is equal to 36. So what will be the sum of up to 15? So we will write the formula. S of n is equal to n divided by 2, a sub 1 plus a sub n. S of n is equals to 15 divided by 2, 8 plus 36. S of n, so 15 divided by 2 times 44. S of n, 7.5 times 44. So S of n is equals to 330. Sigma notation. Sigma notation or summation of notation. Key point. Sigma is the Greek capital letter sigma, which is with a sum or summation. K is the value of positive integers as 1, 2, 3 up to n, or the last term. The notation above can read the sum of all ak, where k is from 1 to n. Example number 1. So we have summation 2k minus 1 and k is equals to 1 and n is equals to 6. So first, we will substitute 2 times 1 minus 1 plus 2 times 2 minus 1 plus 2 times 3 minus 1 plus 2 times 4 minus 1 plus 2 times 5 minus 1 plus 2 times 6 minus 1. And we will get the value of each series. So we have 1, 3, 5, 7, 9, and 11. You will get the total, a total of 36. Example number 2. We have summation 3k minus 1 where k is equals to 2 and n in 7. So we will substitute first the value of 2. So 3 times 2 minus 1 plus 3 times 3 minus 1 plus 3 times 4 minus 1 plus 3 times 5 minus 1 plus 3 times 6 minus 1 plus 3 times 7 minus 1. And we will get the total 5 plus 8 plus 11 plus 14 plus 17 plus 20. So the summation is equals to 75. Example number 3. Expand and evaluate. So the given is summation 2k plus 5 where k is equals to 1 and n is 6. So what will be the solution? Replace k in 2k plus 5 with 1, 2, 3, 4, 5, 6. So we will start 2 times 1 plus 5 plus 2 times 2 plus 5 plus 2 times 3 plus 5 plus 2 times 4 plus 5 plus 2 times 5 plus 5 plus 2 times 6 plus 5. So we will get the total 7, 9, 11, 13, 15, and 17. So a total of 72. So we will find the sum of 1, 2, 3, 4, 5, 6. So S of n is equals to n divided by 2, a sub 1 plus a sub n. This is the formula. So S of n is equals to 6 divided by 2 times 1 plus 6. So 6 divided by 2 is 3, and 1 plus 6 is 7. So 3 times 7 is equals to 21. Problem number 4. Write the series for the sum of the first 6 multiple of 10. So What are the multiple of 10? Answer. So we will need 10, 20, 30, 40, 50, and 60. They are both divisible by 10. Problem number 5. Find the perfect square between 20 and 70 in summation notation. So we will write first the 20, 21, 22 up to 70, and we will find the perfect square there. So what will be the number? We have 25 as 5 squared, we have 36 as 6 squared, 49 as 7 squared, and 64 as 8 squared. So these are the numbers. So if we go back to summation of negation, summation of k squared, where k is the 5, and 8, and m is 8.